Okay, this is Mario once again, and last night I finished this drawing here. This is more like what I'm trying to do here with this kind of similar to that setup there, but not quite. This is more for an adult size go-kart attachment, if you will, because it's not truly a go-kart in the sense of a full go-kart. The motor or the control system is going to be this puppy right here. This is a hoverboard or Hover 1 Rogue model. And if we look at this model right here, what I have done is I removed the, as mentioned in my other video, I removed the connector here, the on-off button, which would turn on when you fold this back horizontally. There's no external switch here, which is kind of silly. As I mentioned several times, putting this switch here so when you close it, it automatically turns on. They should have left that externally so that people can turn this on after it's been assembled and not when this thing hinges back horizontally into full position. I guess they thought, we may as well include the switch to automatically turn on the unit when this is ready to run and put in the horizontal position with that bar. That this one has the tie bars at the bottom, and it's hinged on the sides here, so these wheels kind of pivot. It's a lot of complexity here. So what I did is I put these 3/8 inch bolts by 1 inch in length, and they're fairly tight there with washers and lock washers, so that's not coming done. It's horizontal, but if we look at this, the reason why I opened this up is because I want to focus on this setup here. Most hoverboards, like this one here, this whole thing pivots on the center section right here. This has a tube inside, and this whole assembly pivots to execute a left and right turn, on top of having the regular switches for forward and reverse. So this whole thing needs to pivot in order to turn. What they did here is they maintained this. Once this is of course locked in position horizontally, they put this twisting here on these brackets here, on these foot pedals or foot plates. So they pivot right there, and it's got some heavy duty springs here. But you can see how that's how they execute the left and right turn here. It's a mirror image on this side right here. Very clever the way they did this. Aside from the hinging here, which is they could have just gone straight here and just maintained this as a regular hoverboard and maintain this setup here, which I really like, because this keeps this nice and clean. And you can actually just put I guess they did that in order to introduce this handle here in the center. They figured, if we put this in the center, then there's no way we can make this turn like the regular hoverboard. So let's put the pivoting on the plates underneath each foot, which is very clever. So I really like that. This is already assembled, bolted like that, and I need to install the. There's not going to be a charging jack here because I like using external batteries, Ryobi, these Ryobi batteries. Where are my batteries? So I took them inside to charge. But the 18-volt Ryobi batteries, 2 of those in series, will power these things typically. And so I am going to make a connector here for the battery. It's got the XT60 connector somewhere in there. There's an XT60 connector. There it is. The XT60 connector is there. So I'll probably just cut a hole here on the side, as I've been doing the other hoverboards, just to bring out the battery out externally. So it's got some nice lights too. I want to maintain that. So this whole setup here, I was thinking of doing this as foot pedals in front of the trike. So I can either have this on this T-frame assembly. I can either have that right there, with the front wheel. This has that caster wheel right there. It's an 8. I think this is an 8-inch wheel. 2.5 4 is the size of the hub. So if that is 4, 5, 6, 7, 8, yeah, that's an 8-inch tire. So once that's there, it'll look like that, and then this, of course, this is done with EMT tubing and macro pipe connectors, because I wanted to do two versions. One with this 1.5-inch square tubing, and another one with that, to see which one I really liked better, the best. I'm really liking this right here, because it's very much in line with this setup that I have here, and this is my frame for a man carrying a helicopter. So this I'm planning on putting it either there, or if I want to go with these bars, just as your typical way of controlling these adapters, for these hoverboards, I'm going to have to bring this back into the back here somehow, and put some kind of a bar control here to control the these foot pedals, like that is done. So this is going to remain separate anyway from. Let me put this back. That's going to remain separate from the wheels, which are going to be, the wheels are going to be right here. And I've already thought about doing this with the same brackets. These are the brackets that are, those hinge brackets. So I'm not using the hinging, but I do need this part right here to support the wheel. So that's probably going to go right there. And last night I was cutting these plates right here, which I'm going to weld underneath this 1.5 square tubing, and then those bolts will come up through this plate right here. I'm going to have to drill 2 additional holes right here, and that will be my bracket. Now I also thought of using those U-shaped brackets, but I just couldn't get them fast enough to do this, and I'm kind of eager to do this, so I'm just going to weld these plates. I already cut them, they're already drilled, so all I have to do is just drill 2 additional holes here, and once this is connected to these plates right here, that'll be a permanent setup, because this is going to be welded to this square tubing right here, it's steel tubing. So that's going to be my setup there for the support of the wheels. What I like about this is the simplicity in making these this fairly quick assembly here. Just drill holes, for these T brackets. This is my last set of brackets. Unfortunately, the company that was making this, they ran out of these things. It's the good stuff gets is always either they run out or they don't make it anymore, and the crappy stuff is always out there. So I was fortunate to get 2 orders of these brackets. That's how I did my other go-kart, and I had these 2 left. Unfortunately, I would like to have some more of these brackets, the same thing with the same dimensions, which work out really well. These are 3-inch increments, so I can even use these with my perforated square tubing, the telescopic square tubing, because this is a 3-inch increment right here. This not I don't know if that's 3 inches or not. Let's measure that. That's a 2. That's about 2 5/8. 2 5/8. So that I know these are 3 inches. 3 from the center line. Let's see. Yep, that's 3 and that's 3. So anyway, great brackets. I hope the company they restock these things so that I can buy more of these, because I really like these for building stuff like this. So so that's my back end. How as I was mentioning, how I'm going to do the control. I can either put the whole paddle system back on here and figure out a way to control that, like it's done with those bars right here. But I'm also going to build this one right here. Kind of eager to build this one with the EMT tubing, bend the EMT tubing in such a way that it gives me that setup right there, because these wheels are 10 inches, so you can ride high with these things. As I mentioned in my other videos, I don't want to do the same thing that people have been doing by putting foldable chairs and lawn chairs. They put them on top of the framework, which typically sits above the hoverboard. It's much higher. You're sitting way up here, and so what I want to do instead is bring lower that lower than the height of the board, and that's the reason for these bends right here. Plus, I also wanted to establish some suspension without having to go to shock absorbers and the extra hardware and complexity. And so that's how it's done. If you'll notice on this helicopter frame that I did, I bent these. This is about I would say about 20 inches from the ground right there, and that's just a temporary chair that I have here. But it's very much in line with my quarter scale coaxial helicopter, which is the same thing here, except in quarter scale that I show in videos, working and flying in my backyard. So, but this also gives some kind of cushion here by the bends here. It's not going to be as sturdy as your typical one. That's a 3/4 EMT conduit. It's actually 0.947 something, the outside diameter, and it's got about 1/16 wall, unlike a regular iron or steel pipe, which is 1 inch, and has I believe a little bit thicker wall. But this stuff works great if you don't go too wild on the design and the bends. That bend right there is able to support my weight with just a little bit of cushion there. So if I were to say land hard on this, of course I don't plan on flying this 100 feet in the air. This is just for hovering, maybe 10 feet up in the air, 5 feet, just hovering, just to get the sense of weightless. And so if I were to come down hard, it's got some sort of suspension there. It's very much like the skids are done on regular helicopters, except that I turned that 90 degrees from the typical setup, with the skids facing forward, and this is the opposite way, or 90 degrees setup. So this is where I'm at right now, and as you can see, I was talking about in my earlier videos. I wanted something very slick, and I went to sleep with this. Go back to my shed here because it's hot outside already. I went to sleep with this concept here because I was doing this till 4 in the morning. I was going to go to bed actually at 12 o'clock because I was pretty tired, and then this idea, I started sketching and doodling on just by hand on some napkins, and I go, I gotta put this on the computer. So right away I got in the computer, and when it was done, it was 4 o'clock in the morning. So I do get my 8 hour, 9 hour sleep, so I am refreshed and I'm ready to pump this guy out. I really like the way this is coming out, and this is the way the MIA microflight way. This is the way I really like doing things. I as I said before, I just don't build one, two. Sometimes I build a few of these things full scale, or if it's just a model, I build dozens of these things. I just put every idea down, especially in scale model form. You can whip those out fairly quick, and you can if you want to change something, it's not that costly to do that. All you're doing is just doing it in tubes, or just inexpensive materials that you can whip out a lot of designs and just prototypes in scale, in model form, to get an idea what if that's the look, if that's the what you want. But this is what I want. This is this is my style, the MIA microflight way of doing things, and I just explained the reasons for lowering the center of mass on this. So it's got a lot of cool features, and it's done with EMT tubing and maker pipe connectors. So this design right here, I will be sharing this on the maker pipe website if they haven't if they don't already stumble on this video right here, which I don't mind if they lift this and put it on their site. In fact, I'm happy to that they can do that, because it's just another way to use those connectors, other than the thousands of ways that these maker pipe connectors and EMT tubing is used by daily by so many people that build things with these connectors and EMT tubing. Yeah, I already have a go-kart, a real full-size go-kart. You've seen that, my yellow go-kart that I've been showing in other videos. I just ran that, and it's running great with all the modifications that I did. And now I want this. I want this mainly. The other reason why I want this is because my backyard, as I've been saying, is there's a lot of dirt here. I clear a lot of this. Used to be rock, about half inch to 1 inch rock pebbles or whatever you want to call them. And so I removed a lot of that with just one of those small bobcats. My neighbor kind of helped me do that, flatten out this area and just remove a lot of the rock. So a lot of the rock I've used on the side walls, to reinforce the fence that goes along that perimeter here. It's a nice corner area here, which allows me, to do this. And so a lot of that rock was moved over and created these banks of rock, and that's the reason also for that plywood, not plywood, but 2x6s treated wood, all the way around the perimeter there is just to hold that up against the fence. Not that it requires these fences require support, but I did that just to bring out all this rock because I had a lot of rock. This was all rock, and so my intention was to do a track, like a little racing track here, which I did, but over time, some of these rocks get blown back into the ground, and I have to clear that. So the one option was to clear that and cement that. Cementing here, putting concrete, it's very, very expensive. If and I really don't want to spend that kind of money, on something like this when I can. There are other options. So there's so many options here. I wanted also to keep it as a dirt runway so that I can run go-karts, not go-karts, but radio control. Those trucks, those little truck models, so they can run, and it's perfect, for running that. It's I believe this is 5 foot. I made it 5 foot wide, and it wraps around that area there, goes back, and then. Can even go in the center here, and I did sort of a path because I wanted to put a bridge there. So, and anything in between that's not track, I wanted synthetic grass, and I may do that. I'm considering doing that just to clean this area and just finish this area. So that's the reason for making this also, because with my regular go-kart, with both of them, the yellow one and the one that I did with this 1.5 inch steel pipe or tubing, it just they don't, because they're low riders, or they're more for flat ground asphalt, concrete that's flat, and it just doesn't, they don't have the power to go through dirt and in a little hills here. I have a small hill that's on that area right there. You don't see it, but it comes up here and it goes up a little bit, and the regular go-karts that I have, they struggle in this area right there. I already tried that. And so what I want to do is I want to build these guys here, which will have a little more power, and these wheels are a lot higher, and this is a lot beefier, and it's got it's got some sort of suspension here. And this is the reason also why I'm calling this off-road, because it's going to be more, for areas like I just explained. It's going to be a little more sturdier to do this. This system right here with the levers, it works, but I rather have the steering on the wheel, so that I can, it's just like a regular steering wheel, so that I can control that with more precision. Because these things, they take a while, to get adjusted to. And these bars on the side that I'm showing here. So I may also opt for just a steering wheel here on the attached to this caster wheel here, because this used to be for a lanyard before, and I'm repurposing this for this project right here, because I took down my lanyard. There's some, it's kind of hardly used, and you really have to go to the desert, out in Nevada, where they run these things, to really get the full effect of a lanyard, because those are powered by wind, just a huge sail and three wheels, and you can have fun that way. So unfortunately, I don't live near that area, and it's just a lot of work to take it there. So I took it apart, and I am repurposing that caster wheel in this project here. But this caster wheel does have two holes that I drilled on the sides here, as you can see here on this one. yeah, we can see two holes here, and I had these bolts here for footrests so that I can also maneuver this with my feet. So I can, I think I can attach some kind of a bracket here, outside bracket, that comes out of the wheel and into just a regular steering wheel. That way I can maneuver this with more precision instead of using these bars. The only thing that I have to do here is now I have to introduce some kind of a switch on my throttle switch so that I can do forward and reverse. Now that can easily be done, with just a throttle, just one of those potentiometer type Hall sensor throttles, and just connected to the electronics. Tap into where these switches turn this forward, reverse. As far as turning, I don't need the electronic turning here, where one wheel spins forward and the other one spins backwards, because this would be doing my steering for that, my left and right turns. So that's another option. So many ways you can do these things. God, I'm getting bitten by mosquitoes again. Freaking mosquitoes. So yeah, this is where I'm at, and I was going to capture this. It's probably going to be video number 6. Mario once again with my microflight. And yeah, this is looking pretty spiffy, if I may say so myself. Stay tuned for more.